This is a dumb thing to be doing.
Yeah.
Should I do it more? Or I don't think Steve would be happy if I did it more.
Ooh, fire. Hey, get that. There it is. Hey everyone, today we're doing some fire testing. So we got the NZXT H1 case in. This is a case that has been stopped from being sold by NZXT, and that's because of a safety issue, NZXT's words, later changed to a fire hazard issue. And this stems from a PCIe riser that is faulty. It's not an assumption, it's not speculation, it's not an educated guess, it was just faulty. And NZXT is issuing a kit to try and repair it to not make it catch on fire. Presumably this uses vinyl screws instead of metal screws, but we're gonna walk through it today. We purchased this from one of our Patreon subscribers, Carl, thank you very much, and now we're gonna try and light it on fire. Before that, this video is brought to you by Thermal Grizzly's Conductonaut liquid metal. Conductonaut is what we've used in all of our liquid metal and delit thermal tests, capable of dropping CPU thermals significantly when replacing the stock thermal interface. Lower CPU thermals don't just allow better overclocks, but also lower noise levels because the transfer efficiency is increased. The mix of gallium and indium makes for a thermal conductivity of 73 watts per meter Kelvin, outclassing traditional pastes significantly. Learn more at the link in the description below. Okay, so here's some bits and pieces. We have some shots of the NZXT H1 assembled that we'll show at some point during this, but we've taken it apart to do the testing on a bench. And this is the chassis for the case. So that's obviously the inside of the metal walls. A power supply comes installed in here. The riser is installed in here as well. And other than that, it's just a standard chassis. There's a liquid cooler that's pre-installed also, but those components are not problematic. And then internally, here's a power supply. Our understanding right now is that this is not part of the issue. Power supplies certainly can cause fires, but from what we know today, this isn't it. This is in the case, though, it is included with it. Now the issue, from what we could gather, is that basically, if you look around at videos and photos of systems where people have had their H1 catch fire, a lot of people complained about video cards dying, about other components dying as a result of the fires, and that's expected. Once you introduce a fire to a computer, things will start dying, and you it might not be restricted to things that actually caught fire. It could just be stuff that got influenced by the change of power delivery as a result of the fire. So lots of things could happen, but that is the screw that we're pretty sure is causing the issue. And this one should be fine as is, because the Patreon viewer who sent us this case obviously didn't experience a fire. So currently, from what we understand, it sounds like it's either you had a small fire or components just go up in a puff and you didn't necessarily notice it. It just doesn't always make a big show of things, or you didn't. And in this case, the user didn't. So what we'll do is we'll tighten the screw a little more to see if we can make it produce a fire to simulate the issue. So that's how we understand it right now. The riser is pretty simple. Otherwise, it's just a PCB on top of a piece of metal with a metal screw through it, and then a plastic shell to guide the cabling to the other side, where you get another plastic shell, and then it sockets into the motherboard. So we're going to connect this stuff. I'm going to be connecting a couple sacrificial components just in case, and we could power this without a motherboard at all. We could do it with just power and jumping things, but we're going to go ahead and build a small system. So this is a VT5450 2GB card. We have a couple of these, so it's fine. And the goal here is to determine if we can reproduce the issue or not. And if so, what specifically is the cause? Now, NZXT is doing replacements, and they've recommended you stop using the system if you feel uncomfortable about it. You can email, I think it's h1support@nzxt.com or something. We better use a lot of thermal paste because we need to conduct the fire into the heatsink. So NZXT's trying to take care of it. Basically, if you feel uncomfortable, contact them. If you bought it recently, maybe just return it. But they're sending out replacement kits. We have one of those on the way as well to see if it will actually solve the problem. But my guess is it's going to be a nylon screw All right, so this first boot should be fine because Carl was using this without issues. And not sure how long, but he got rid of the case and not expecting issues. And then we'll boot it after that with the screw tightened and we might see an issue. Okay, no fire as expected. Let's tighten that screw. Okay. If I do any more on that, it's going to start stripping, so I'm not sure what NZXT is doing to get that to be too tight, but it's the same thing they've done for years, I guess. Okay, let's try it. Not yet. More scratching to commence. Okay, let's die. Man, this is very disappointing. Okay, so it's been a couple of weeks at this point. We put it all away after we couldn't create a fire with the previous attempt. But even though this issue is theoretically resolved with nylon screws or whatever it is NZXT has in its repair kit, there are still several things we haven't tried, like installing anything in the chassis, which could change things like the grounds or power supply positioning might matter relative to the GPU and the pins on the riser cable. So what I'm gonna do now is call in Patrick to help out with the next section. So the plan is Patrick is going to explain some of the electrical wiring and the path that current might take and why a fire might start. And then Patrick will work on assembling and testing the system. So hopefully Patrick can give us an answer as to what's actually going on here.
All right, so in our first test, we tried to get a fire started and didn't do so well. And so I think we know why now. The idea is that we didn't have the motherboard tray connected to the power supply, which kind of opened up the current loop that was causing the fire in the first place. And so what we'll do is we'll try and show you guys how connecting the motherboard tray to the power supply will probably get us this fire situation. What's happening is we're having a closed current loop where we shouldn't have one. And I'll demonstrate this. So here's how it's supposed to happen with a good working system with no problems. You got your power supply, and we're definitely going to oversimplify this diagram. And your power supply delivers 12 volts out this way to the motherboard. So we'll just do a little motherboard right there. And then, again, super oversimplified. We're shooting back, creating a good power loop. If this is my 12 volts up here, this is my ground down here, then what we've got is we got nice little current flow, right, like that. And then if we want to extend that out to the graphics card, the graphics card's going to go over this PCIe riser cable. So I'm just going to write in PCIe right here. And then extend that 12 volts out this way. And then it's going to hit our graphics card down here eventually. And so then our graphics card is going to complete the current loop by sending it back down some ground lines to the motherboard, and then the motherboard is going to send it back to the PSU, so we get this nice current loop like this. That's how it's supposed to work. And if there's no graphics card here, then you have no loop here, so there's no power going out this way. So if we have like our PCIe riser cable and no graphics card connected here, there should never be any current flowing through the PCIe slot on the riser cable. But unfortunately, what's happening with this NZXT problem is we have this screw that is making contact with the 12 volt line. And Patrick will show you guys that, like with the multimeter, how that contact is happening in a little bit. But so basically there's a screw that is making contact with the 12 volt line. Just gonna kind of, you got a screw here. And so this screw is happening, and then the screw is going through the motherboard tray and the screw is going through the PCIe riser cable, and the riser cable is attached to the motherboard tray. The motherboard tray is then attached to the case, and the case is attached to the power supply. So what we effectively have going on here is, hey, look, we've got another path to ground, and so now we have 12 volts to ground. And so on this PCIe riser cable, we have a little teeny tiny wire, almost like trace size, that is having way too much current going across it, which is in effect making it a heating element. So this current loop that shouldn't be happening is happening, and then this little tiny wire carrying 12 volts on the PCIe riser cable is getting way too hot. It's melting the plastic, and boom, we get a little bit of fire. So to eliminate that, what NZXT did is they sent out some non-conductive screws, and so by eliminating this grounded connection that shouldn't ever be here, they've solved their little problem.
Hello, I am also Patrick, and I am going to map out some of the PCIe connections that we think are happening. We have a couple known good PCIe cables here that I've chosen randomly out of the bin. These are cables that we use for testing on a regular basis, and this is the PCIe riser cable out of the NZXT H1. So we'll see whether the pinouts of these match up with the H1. So in a general sense, this is power and this is data. So this is what we're looking out for. This is the side of the PCIe riser cable that is a problem on the H1. This is where the fires generally start, which makes sense because this is the power end of the connector. So what we're doing here is we are just continuity testing from each of the pins in the power section of the PCIe header to this section right here, which is under this silver screw in the NZXT riser cable. So there are 11 pins here. They are numbered 1 through 11, and they have an A side and a B side. And you can see inside the PCIe slot, there is an A side and a B side. It doesn't really matter which is which for the purposes of this, but I will be matching it up so that this side is the key side and this side is the side with the screw on it. Okay, so just to establish, we've got a good connection there. So let's work our way through the top row. 1, 2, 3, 4. I've already marked 4, 5, 6, 7, 8, 9, 10, and 11. And then on the bottom row, 1, 2, 3, 4, 5, 6, 7. So both sides on 4, one side on 7. So we can, on this other riser cable, go through potentially much more quickly. So both of these are good riser cables. Both of these have connections on these particular pins. Here is the NZXT riser cable. Nothing on 1, 2, 3, 1, 2, 3, 4, nothing on 4, 5, 6, 7, 8, 9, 10, 11. So bottom row, 1, 2, 3, 4, 5. Okay, so we can probably shorten that section quite a bit, but the bottom line is that these pins right here that are connected to this screw on the NZXT riser cable are 12 volt pins, and these 3 pins that are connected to the corresponding screw hole on these riser cables that we know are good, these are marked as ground pins. So it seems like it would be a bad thing for the 12 volt pins to be connected in the way that the ground pins are supposed to be. So if everything goes according to plan and we assemble this case or assemble it in the way that other Patrick has just specified, we should be able to start a fire.
Yeah, there we go. And now we have all kinds of good metal connectivity.
Okay.
And so what we're hoping for is we're hoping for some fire and flame right about here.
So what I'm wondering is, if
see if you can do that continuity test, see if that happens.
I'm just wondering even between the, so like.
Oh yeah, the chassis, yeah, exactly, good call.
So.
Yep, that's good. Now do the same thing. Let's just continue that thought process, right? And by the way, I don't think we need a GPU at all. Like, if you don't want to sacrifice this GPU, we don't have to burn it up.
We can sacrifice it, but we could, it's...
Because we're going to create a ground loop with or without the graphics card.
Okay. You live another day.
Okay, so if we're good from here to here, then the next thing to say is, okay, so then we said that this thing was making a connection to this, which it shouldn't have been. So then we go like that, right?
Mm-hmm.
So now we know the ground part is good. So now is the 12 volt part good? So on a PCI Express slot, a 12 volt is where? Like pin, what, 1 on the bottom?
2 and 3 are probably safer bets because they're both.
So I got there. Well, that's not good.
Okay.
So 12 volt and ground are currently connected, which is not a great thing. Okay, here we go. See what happens. And if it doesn't get warm, I'm gonna do something stupid, okay? No, nothing, okay. Yeah, it's tripping immediately.
Yeah. Interesting.
That's what I was expecting to happen. Remember I was telling you that if the PSU was a good PSU, then the overcurrent protection would trip?
If it is possible to buy an H1 with a different power supply.
Or just go ahead and throw together the case, just put everything back together.
Sure. Would that help?
Because what could be happening there is that the case could be providing enough resistance so that it doesn't see the perfect short, so the power supply is not tripping, but it provides not enough resistance to not melt the cable.
So this is the affected area, and then this is the tray that we had hooked up earlier. And then there's at least one connection here, and then a couple more connections here. Like potential places for it to connect, and then here, and then connected to the power supply here. So I bet when I do something stupid, I'm holding the handle, so it's fine.
So just to be really clear here, the sparks that are happening on the back of the computer, that's just confirming basically our testing methodology approach to this, which allows us to determine if a short is occurring that could potentially cause a fire, but the sparks on the back aren't going to happen unless there's a short occurring and there's scratched paint or exposed metal. So that was a separate part of our testing methodology to determine if the root cause was what we thought it was, but is not the issue that NZXT had. It's the issue NZXT had is with the PCIe riser. Okay, so it's back to me now. As I understand it, Patrick was able to create some sparks off the system. So now what we're gonna do is I'm going to stick some thermocouples in a couple spots on the casing and in the PCIe slot. And my goal is to actually get the temperature and monitor if the PCIe slot itself will start to heat up to a point where it could potentially light itself on fire. So we're gonna try that, and depending on how this goes, the next step is to throw to other Patrick and have him do a diagnostic on it and explain why this is all happening and talk to you about the current flow. So what I'm gonna do is get some thermocouple readers, and my plan is to, first I need to insulate the end of this wire so that it won't short something. The plan is to shove one end of this down near the 12 volt in the PCIe slot, and the point of insulating it is so that it can't create a short. So this would allow me to get the temperature in the PCIe slot in case the fire that we've seen, the one YouTube video we saw, in case it's originating there, because currently it looks like it's sending 12 volts to ground. So I'm thinking that that should get pretty hot. I'm also going to stick a thermocouple under the screw right here. So I'm gonna loosen this just a little bit, not much. It'll still make contact as expected, but I'm gonna loosen that and get a thermocouple up under it so that we can take a measurement at the screw. Then I'm gonna stick one more on the back over here near this screw.
Yeah, so if the 12 volt pin and the screw are connected, and then that screw and the power supply is connected. And then we should be giving the 12 volt a way to get back to the power supply. Yeah, look at this now. So I loosened that screw up in the PCIe slot, and I'm getting 12 volts between pin 4, which is ground,
Yeah.
and that screw.
Okay. And a second ago, was it 0?
It was 0.
Okay.
So now if I probe,
So then I tightened it too much.
yeah. So if I probe on pin 2, in this little guy, pin 2 is 12 volts. So now I've got voltage flowing through here again, and so then this.
That's just at 0.
Yeah, so then if I do this is 12 volts to the power supply over here, which is ground. That's 12 volts. Okay, good.
Okay. So I
Uh,
loosened the screw and tightened it when I put a thermocouple in there. So does that just mean I didn't have exactly the right or wrong
yeah, is this screw really that
tightness?
Oh, shit. What if the trace is so small that, you know how as you turn the screw, it has like an angled grind to
Oh,
it?
I see what you can see. Yeah, okay. So like the...
It misses the trace.
Yeah, okay. So that would be why
That's some
Fewer-
crazy-ish.
fewer than 10 units had issues.
Right, because what if the screw just wasn't turned the right?
Yeah.
Well, now let's verify that what the heck I just did is correct. So this thing should be ground, not 12 volts. And so if we just do a continuity test, we're good. So if I go to the 12 volt pin, if it's broken, it's going to beep.
Okay.
Let's double check that. Pin 1, pin 2, pin 3. That's the ground right there.
Okay.
So there's no continuity with the ground right
Yeah, right.
now.
Okay.
Damn. That makes a lot of sense as to why they're like, let's fix this, but then they're also like, not many units had the problem.
Yeah.
Because it was a crapshoot.
Yeah. Okay, so now should I
So
try
now,
my test again?
if you want to do your wiggle,
Yeah. Do the wiggle.
well, just see if you can get spark, but without doing anything, just see if you can get
Okay.
spark.
I wanted to get a thermocouple in there, but okay. Now, one thing it was also not doing for me is shutting down when I tightened this. All right. Ooh, big sparks. All right.
Yeah,
cool.
so it's just like arcing, right?
Yeah.
If you get the distance correct,
Yeah.
like a spark plug gap, then you're going to get arc. Steve,
Yeah.
will you move the PCIe screw?
Yeah, it's steel. What do you want? Looser?
Just looking at the meter down below, seeing if we get any resistance change.
It sparked.
Yeah.
0.3. It's pretty loose right now.
Yeah.
Ooh, fire. Hey, get that. All right. There it is. You have a good shot of that?
Yes.
Okay. Thank you, Stone. So we got 2 angles. Let me know when you think I should put it out.
You tell me, camera guy. Oh, jeez.
So we got it, and now we just have to diagnose what that was. I'm
Your
pretty
thermocouple's going up a little bit.
Oh yeah, we're in 140, 205 degrees on the thermocouple, 140 on the other. All right, do we have enough footage, you think?
Probably.
Does this prove the point?
Okay.
I've had this shit for like 5 years. I'm surprised it still works. Never actually used it. Okay, so we vacated the office for a little while and bought a floor fan after that. But I'm gonna have Stone back on in a moment to go through a post-mortem and explain why the fire started that way, what caused it or what we think caused it, and the severity of the fire. But before we get to that section, I want to talk more about the solution that NZXT has out there. So we bought another case. We have it on the way. It is from after NZXT resumed selling it. So it supposedly has the fix in it. Now, if that fix is just 2 nylon screws, they might not have really fixed it. They might have worked around the problem. So a couple of things that I want to talk about before we get into the post-mortem of this. Number one thing is that it was very hard to make this fire start. That doesn't mean that it's impossible. So NZXT was correct in that NZXT said, very rare issue. They said fewer than 10 units. This did get government involvement, so I'm pretty sure they wouldn't lie about that aspect because there was government agency oversight. Seems unlikely they'd lie about fewer than 10 units, at least when they first reported it. So they said it's a rare issue. After what we had to go through to make it happen, we agree with them. However, it's an extremely severe issue. It is a serious safety hazard where in the one video that was out there from a user, the fire sort of starts and then extinguishes itself. Ours didn't do that. I had to extinguish it. So you could feasibly see a scenario where this could cause an actual house fire. And house fires have actual real-world consequences. So this is a very serious issue. And if you have one of these cases, our main points to you would be as follows. One, if you have not had a fire or an event similar to this yet, you're probably, asterisk there, okay, except it's still possible to happen. And the ways that, from what we understand right now, it would happen would be if the thread on the screw just happens to align with whatever exposed trace there is in the PCB, then that seems to be what is the starter for the fire. So that's from what we understand based on our testing here. And because of that if it is an exposed trace like we think it is in the PCB, then simply putting a nylon screw in doesn't really fix it. Now, a nylon screw or a plastic screw, it's not going to short 12 volts to ground, but that problem is still there, lying in wait. So if you sell the system later, if you take out the riser in 4 years, you're like, oh, I forgot I had this sitting in the closet and I need a PCIe riser, you take it out and you use a metal screw, it could cause this issue. So we would very strongly suggest that you definitely get the replacement kit with the nylon screws. Personally speaking, I would not be comfortable using that riser at all, with or without the nylon screws. I would personally want a completely different PCIe riser in there. And we tested some here today that look like they should be fine because they're wired properly. As for the thermocouples and what those experienced, the screw actually got hottest first, so this sort of confirms our suspicions that that's where the fire starts. And then it spread to the PCIe slot, and the screw hit it was close to 200 degrees, and the PCIe slot actually hit about 240 degrees Celsius. So then, the severity of the issue, very high. The frequency of occurrence appears to be low. What we did to make this happen was basically adjust the thread angle of the screw by turning it until we could find sparks on the back, which indicated to it, or until we saw a resistance change here, that would indicate to us that the problem is going to happen. A couple quick things. So we did replace the screw, but we found out that that doesn't actually matter. And with the screw that we ended up using, it has the same thread pitch, same spec exactly as the black screw that comes with the case, except ours was not painted. And that was, I don't know if we left it in the video, but in the beginning part of the video, we were trying to do everything we could to expose metal, and so that was part of it. But clearly, because this was an issue that affected people, it's recorded, they did an official functional recall in a sense, or at least issued a fix and a statement. Because we know this was happening without changing the screw, we can state confidently that changing the screw is not the reason we got the effect we did today. It was just something that we did along the way to try and get the effect. But you could very well get this same fire with the black painted screw. Okay, so now that we've gone through all of the sort of important disclaimers and saying you should replace this thing, let's get over to Stone, who's going to walk through the post-mortem and talk about why he thinks this happened.
So now that we've got our fire, let's see if what we thought earlier was actually what happened. So earlier we thought that there was a short circuit. Basically, the 12 volt was hitting ground, and that's a bad thing always. And we actually thought that maybe this wire right over here, this guy, is what was catching fire. But it turns out that it's more likely, according to the camera stuff, that it was near the screw itself and probably in one of the holes to the left of the screw if you're looking at it from this point of view. And so what we think is happening there is we think that a trace in the PCB has a 12-volt trace somewhere exposed there. And as the screw makes contact with that trace, allowing that 12-volt trace to go to ground. And when I say go to ground, what I'm talking about here is through a few steps. So if you look at the screw goes through the PCB and then attaches to this motherboard tray. The motherboard tray is then attached to the chassis, and then the chassis is attached to the power supply where it can go back to ground. So that completes the circuit. And so we have this short circuit that is happening through this screw. And what's interesting is that if you have the screw in just the right position, it never occurs because the trace is tiny and the threads on the screw may or may not be making contact with that trace. So if you move this screw at all, it can then make contact with that trace, which then causes that bad heat condition. And so a little bitty trace with a lot of current running through it basically acts like a heating element, and then it ignites whatever part of the PCB is catching on fire. And again, like I said, I think what's happening is that there's a little hole to the left-hand side of the screw. We think that the fire is catching somewhere right in there first, and then it works its way across the screw to the right-hand side of the board. So if you review the video from the other user on YouTube and you take a look at theirs, originally, again, like I said, I thought that I was seeing light here first in that video, but on a closer look, the other Patrick said, hey, take a look at the motherboard in this section right over here. And what you'll see is that this part of the motherboard is dark, and then it lights up before any of the light over here hits. So that's a reasonable conclusion to say that we've got the fire starting here, causing light on the board, and then you'll see the light continue to work its way from the left-hand side to the right-hand side of the image.
I want to get back over here too for one other note that we had. So, believe it or not, this is no longer useful to us for testing, for just about anything. And one of the things that we did before lighting it on fire was check the other screw on the other side. And because it's all fused together and melted now, we can't go back and validate this. But we had reason to be concerned that potentially the other screw might have also been shorting to ground.
Yeah, exactly right. Yeah, so again, we've got a screw on the bottom of the PCB riser that we know is problematic. And then according to the testing that we did, where we were just testing for continuity, if you move the screw on the top, it's possible that could also be bad in your PCB riser. So,
and we, like I said, we can't go. We would normally validate this, and we just tried, but it's all fused together. It's melted. We can't go back and check it again. So, our solution then, because it's possible that it's a problem, if you're one of the people who replaced the lower screw down here with a zip tie or with your own nylon screw because you didn't want to wait for NZXT, then our suggestion is go and replace the other screw too, just to be safe. It may not be a problem, but just in case it is a problem, replace that one as well with something that's not going to be conductive. So that's going to be it for this one. This took weeks for us to finally cobble together and figure out. It is a difficult issue to create, so we really want to emphasize that. If you have the case and you didn't get the replacement kit, you shouldn't necessarily panic if you haven't already had a problem. You probably would have had it right when you tried to turn it on. Couple things though, adjusting the screws basically ever could cause a fire. And also if you do the nylon screw replacement kit or whatever it is, or you've done zip ties on one and not the other, either way, we feel that you should replace the entire PCIe riser with something safer. Nylon screws will work around what we believe to be the problem by removing a point that can bridge 12 volts to ground. But if ever you reuse that riser or put a different screw in there, then feasibly this issue could emerge if, as we believe, there's a 12-volt trace that's exposed somewhere in the PCB to whatever metal screw you put through there. So we think you should replace the whole thing. We think NZXT actually, if it hasn't already, should definitely investigate our findings here. And if NZXT finds that there are traces exposed, like we have evidence to support, then NZXT should probably be remanufacturing these cables and fixing that and shipping out a replacement cable. But we've reached out to NZXT with questions, and we hope to work with NZXT on finding a resolution to this problem. Because although NZXT has a patch kit, currently, from what we know, we don't believe that to be a full fix, more of just a workaround or a sidestep to the problem that's good enough, but perhaps still maybe a little bit on the irresponsible side if someone were to ever put a metal screw through there. And then to re-emphasize, definitely, if you're one of the people who replaced the bottom screw and you stopped there, replace the top screw too, just to be safe. And we do have another retail version of the brand new updated H1 coming in. We plan to test that one and see if the issue still exists. So if we find that, we can still create a fire by switching to metal screws from plastic, then NZXT stepped around the issue, and that's what we'll be testing next. We also are considering cutting open this PCIe riser PCB and putting it under a microscope just to see if we can find any additional information that might be helpful. But that would be a second content piece because this one has been a lot of work already. So there's at least a partial resolution. Definitely get the screws replaced if either one of them is metal, and potentially try to get a replacement riser as well. But we need to look into it further to make a stronger claim on how necessary we really think that is. That's what we would do, though. So that's it for this one. Thank you for watching. If you want to support this type of work, the best way to do it and to support my continual breathing in of fire when we do things like this is to go to patreon.com/gamersnexus or store.gamersnexus.net if you'd like to pick up one of the mod mats or other products on our store. And now, hopefully, I won't lose my voice from standing so close to this thing when it lit a flame. Thank you for watching. Subscribe for more. We'll see you all next time.